right, hi everyone. I'm Evan, and today I'm here to talk about what's coming in Vue 3. You already asked like how many of you, actually use Vue, but I didn't see a lot of hands. Can we do that again? Like, how many of you have used Vue before? Okay, great. So for those of you who don't actually use it or don't actually do any front-end work, this talk is probably going to be a bit of, dense, but hopefully this will make your front-end coworkers' life a bit easier. So that's what we're trying to help the Laravel community with. So a lot of you, if you've been following along with Vue's roadmap development, we actually announced the plans for 3.0 last year, and we've been working on it for a very long time. We are deliberately taking it slow because we want to make sure it's not like we're trying to rush out a new product, because we want to make sure we always make the good decisions, and we want to make sure once we ship it, it's there good to go, because we take stability quite seriously. We don't want to ship a new major version like every couple months and break people's stuff. So we want to make sure if we make big changes, we want to make sure we make them for good reasons. So now looking back on some of the 3.0 design goals, obviously for front-end libraries, you always want it to be smaller and faster if possible. One of those things we really try to tackle is better TypeScript support. I don't know how many of you actually use TypeScript, because from what my perception, type hints seems still to be a thing of heated debates in the PHP community. But even in the JavaScript world, a lot of people are also like, I like TypeScript, I hate it, right? But undoubtedly, there are a lot of Vue users today. They're starting to use Vue with TypeScript, and they're running into problems. Mostly because Vue's current API design really wasn't designed with type friendliness in mind when we first came up with it. So we're trying to figure out a way of providing a middle ground where it still works with what you know about Vue, but provide better TypeScript support. And then we want to have a more maintainable code base. This is both for us, the maintainers, and for you, the users. We want to provide mechanisms that allows you to manage your code base for the long run with a team of a lot of coworkers. And then we want to also expose more low-level features. Some of the internal stuff, like how do you handle reactivity inside Vue? Why do things change when you change a property? Why do the DOM update, right? A lot of these may seem like a black box to you if you only use Vue occasionally. But for some advanced users, they've been asking to get their hands on some of the internal stuff so that they can build some of their own abstractions to handle some more complex use cases. So a lot of these things we're trying to tackle, but let's talk about making it fast first. How do we make it faster? Some of the things are, I've already talked about them quite a bit over the past half years, because this was the original plan when we started working on Vue 3. The first thing is we are changing the internal reactivity, the change detection mechanism, from object-defined property to use, which is an ES5 feature, to use proxies, which is an ES6 feature. So proxies allows us to create a change detection system or an data observation system that's more efficient, and also comes with the benefits of it covers the full language features. If you've used Vue, you probably are aware of some of the caveats when you are trying to mutate data. Like you cannot use square brackets to set an index in an array, or you need to remember to declare all your properties up front, because adding new properties later won't actually trigger changes in Vue. So a lot of these caveats are just gone once we switch to proxies, so this should make people's lives a lot easier. And then, and the side effect is it's also actually faster, according to our benchmarks. And then there's the virtual DOM rewrite. So we're rewriting our core different algorithm from the ground up. So that was actually the first rewrite that started last year. And there are more compile time optimizations, such as making slots compiled as functions by default, making the generated code compiled for templates more monomorphic, which think of it as making the code more JavaScript engine friendly, so the engine has an easier time optimizing the code. And then we also have these compiler generated flags or runtime hints that we can leave in the generated code to make, in general, just make everything faster, right? We've explored a lot of these possible optimizations in the first iteration of the rewrite. And this is where we were at the end of last year, actually. We were already more than 2 times as fast in terms of mounting stateful components. Remind you, this is data from last year. We're rendering 3,000 stateful component instances. And the first rewrite, we got more than 100% increase improvements in both memory usage, and startup time. But it's not good enough, right? In the meantime, we saw some of the interesting strategies that's being pushed out by some of the other frameworks that's in the field, right? There are a lot of interesting things happening in the front-end scene in the past half years, like Svelte 3 was released, React announced hooks, a lot of these interesting things coming up, and we were thinking just making it like marginally fast doesn't really, it's just not good enough. So I went back to the drawing board and tried to figure out like how to say what is the real bottleneck of Vue's performance in terms of updates, right? So for a lot of you, if you never run into these performance problems, just you're probably like Vue is fast enough, but for people who are building really, really large apps, right, this is always going to be a concern. And it's always good to know that without, like, a lot of these performance improvements don't really change any of the way you write Vue code. So the same code just runs faster by changing the internal implementation. So we're always trying to do that. So a lot of you probably know, Vue internally, when you write the templates, we compile it into something called render functions. And these render functions are functions that return a virtual DOM structure. And then we diff and patch the DOM. So this was a technique that's pioneered by React. And it provided some of the benefits, such as it was actually a pretty straightforward transformation from templates to virtual DOM render functions. It also gave you the ability, a very easy intermediate format when you're trying to do like things like server-side rendering or rendering to native targets. So a lot of these benefits is why we chose it, and more importantly, it also allows you to like skip the templates and directly write plain JavaScript to handle some of the really, really demanding complex logic. But the problem is the virtual DOM is really, like in the past that was the misconception. When React first came out, a lot of people like React is fast because of virtual DOM, right? That's really a misconception because virtual DOM, strictly, it is a liability. It's just a lot of extra work. You're always creating a bunch of extra JavaScript objects on every update, and you're trying to walk through the tree to compare them, right? It's not free. There's a lot of work involved. Although at the component level, due to Vue's dependency tracking mechanism, we're already able to ensure that only the necessary components are ever updated when you trigger state changes in your application. But inside each component, it's still a full virtual DOM diff, right? So it's if you trigger a lot of components to update at the same time, it's still a lot of work that's spent in CPU cycles. So how do we get around that? Let's take a look at an example. Imagine you have a template like this. So on the left is the Vue template. So everything is static except for this message interpolation here. And on the right is the actual algorithm that Vue will run to be able to update the message. We actually have to recursively walk down the tree, diff the root div first, then trying to figure out if ID has changed. Then we diff this p. And also this list of children, this list of children, we never know if the order of these p's have ever changed, right? So we need to first figure out if they're actually the same list, and if they were reordering. And then for each item inside the list, we have to then go into the P, trying to see if its class changed, then going to its text content, trying to see if text content changed. As you can imagine, this is a lot of work. Luckily, modern JavaScript engines are fast enough to handle this at acceptable, in acceptable timing, but still,
we can make it faster. Why not? So the performance of traditional virtual DOM is determined, as you can see, not by how many things can change, but by how large your entire template is. So if you have a template of 10,000 static nodes with only one dynamic text interpolation in it, a naive implementation of virtual DOM would still diff the whole thing. Like it would have to walk through the 10,000 nodes just to figure out that only one thing has changed. Right? So this is obviously inefficient. And why can't we just optimize render functions? Why can't we just optimize JSX, say like in React? Why haven't people done that? The reason is when you skip templates and directly write things like render functions, you can write code like this. Right? This is just JavaScript. And with the full dynamic nature of JavaScript, it's extremely difficult for a compiler to tell what your real intention is. Right? You could be constructing something that's completely unrelated in this children array, but you're actually returning it as a list of nodes to render. So this just makes it very, very difficult for the compiler to be smart about what you're trying to do. Okay? And on the other hand, the more constrained the syntax is, say if you have a template, actually there's more optimization that can be done. If you haven't heard about it, there is a framework called Svelte, which offers a template syntax that's very similar to Vue. And it even compiles your JavaScript code as well. So you're forced to write all your component code in a single file. And it analyzes both your templates and your JavaScript. And you have to write your JavaScript in a special dialect of Svelte. But at that cost, the return is Svelte is able to infer a lot more about your intention, what your component is trying to do. So it generates code like this. So it knows that the only thing could ever change is the name. So this is the whole update function it generates for this piece of template. There's no unnecessary work. So now you might be thinking, why don't we just like do what Svelte does and just ditch virtual DOM altogether? So there are a bunch of reasons why we're not doing that. First is full expressive of JavaScript. Although you might not need it all the time, it's still pretty useful. How many of you use Vuetify? A bunch of you? So Vuetify just released 2.0. It's obviously a very excellent library. And if you've looked at the source code of Vuetify, these complex UI libraries are actually, it's written completely with plain JavaScript render functions underneath. Vuetify is not using templates because it has to handle a lot of these complex interaction logic instead of just presenting a bunch of lists, articles. It's not about rendering. It's more about handling complex user input. So it also offers more succinct generated code. So when you look at code like this, or if you play around with Svelte's compiler, you'll see that it generates a bit more verbose code because it's trying to directly translate your templates into imperative operations. And most importantly, we want to make sure there's backwards compatibility. If we ditch virtual DOM, Vuetify will no longer work with Vue. That's just something we never want to see happen, right? And all the people who wrote handwritten render functions, their code will break. So how do we improve, given that we cannot ditch virtual DOM? So let's think about what's unique about Vue. The first thing is virtual DOM. We have virtual DOM as a lower level rendering implementation. It's just the implementation details, if you want to think of it that way. And then we have templates as a higher level syntax, which is something we're all familiar with. And the templates actually provide a lot of useful information for optimizations because with templates, there's only one way you can write a node structure, right? So there's no way you can say, once you write the template is there. It's static. You cannot say dynamically mutate it further in your other code. So what Vue should do in this situation is first, we still provide the ability to drop down to render functions when needed, but we want to maximize compile time optimization opportunities for templates. So we need to attack from both sides. So here we have, in the past few months, we've figured out a new template compilation strategy that allows us to just get around this bottleneck of virtual DOM. Let's start with the simplest case, the template that we just discussed, right? What we want to do is skip everything else. Anything that doesn't change, we shouldn't care about it. The only thing we want to do is just check whether this text node has changed. So how do we do that? if we're just having two virtual DOM trees, right? So let's analyze the structure. And we imagine if we are compiling it, and instead of generating this whole thing, whenever we encounter a dynamic node, how about we just record it somewhere? Say like, here is a list of dynamic nodes you should check about. Other things you just ignore. Okay? So that seems pretty simple. But what if you have node structure changes like VIF, right? Now you have a P that's dynamically toggled by this property OK. And it could be there, it could not be there. So this requires us to be able to handle the node structure changes. So our flat array strategy would no longer work. But if we divide our templates into two parts, outside of the VIF, as you can see, if we think of the VIF as a single node, it's a dynamic node, it's always going to be there. It could be rendering something, it could be rendering an empty node, but it's there. Now we have an outside block with only one dynamic node in here, whose position doesn't change. And then inside this if block, we have a dynamic text node whose position doesn't change either. So now we have two separate blocks. And within each block, notice the node structure is stable. And same thing for V4, right? If we have a list of V4, let's treat the whole V4 as a fragment. So that's one single dynamic node. So anything containing a V4, we just ignore that the things in V4 might change. So V4 is a fragment, it handles itself. Then inside each V4 fragment, we have a stable node structure. So the general idea is we separate our templates into multiple blocks, and these blocks are separated by these structural directives, VIF and V4. Anything that can cause node structure to change, we just cut them out. Now, once we do that, every single block, inside every single block, we have a completely stable node structure. So there's no tree traversal. There's no list diffing. It's just all flat arrays. So we have a block tree, a tree of blocks, if you may. And you would now imagine you have a huge template, and how would that go? If we are looking at the same template that we had before, we would have, this is before, this is the way Vue 2 does things. It does a lot of unnecessary work. And afterwards, really, like, this whole template compiles into one single array containing one single dynamic node, and we just diff that. So with the new strategy, update performance is now determined by the amount of dynamic content in your template instead of how big your template is. So now you can rest assured, like, if you have huge static content that you need to render in a Vue component, they would no longer incur additional performance costs. I mean, we would still pay the upfront cost to first render them, but subsequent updates, they are just ignored. Vue is smart enough to tell that they never change, and you don't need to worry about them anymore. So just to show how faster that could be, let's do an update performance benchmark. So we have a V4 list of 1,000 iterations. Inside each iteration, we have 12 DOM elements nested 3 levels deep. And we have a total of 2 dynamic class bindings, 1 dynamic text interpolation, 1 dynamic ID attribute binding. And we're going to update all dynamic bindings, take an average of 100 runs. And this is the comparison, right? So this is the 2.6, we have 36 milliseconds each update. So that's way beyond 16 milliseconds budget frame, right? So, but in comparison, our new strategy gives us 5.44 milliseconds, and that is more than 6 times faster in this benchmark. So imagine if you're trying to animate something, and this is going to stutter, this is going to jank, and this is going to be butter smooth. That's the difference, right? So that's pretty much it about the new compilation strategy and performance. So as a high-level idea, if you don't use Vue, just know that Vue 3 will be faster. That's the takeaway. OK, so now let's talk about maintainability. Some of the pain points we've seen in large-scale projects. So this is not something that every Vue user may run into, because not everyone builds huge applications. But some of Vue users, they do use Vue to build huge applications. And they have a team of maybe 10 to 20 people. They have to work on it for God knows how long, maybe a year, 2, or 3. So in these type of projects, maintainability, especially long-term maintainability, and the ability for you to understand code that's not written by yourself is extremely important. And this is something we've seen Vue's current API design kind of runs into limitations in some of the projects we've seen. So first is not ideal TypeScript support. A lot of these large projects, they want to have type safety, so also to leverage better IDE support in a lot of cases. And some of you might have experienced this. Have you ever seen a massive component that just grows bigger and bigger every time you add a feature to it, and it grows so big that nobody wants to touch it anymore? Everybody's like, no, I can't just no, I just can't figure out how, what's going on here, right? And then there's this lack of a clean and cost-free logic reuse pattern. For example, sometimes you may be wondering, hey, I have this little thing that's I'm doing over and over again across all these components. I want to extract it out, reuse it, but how, right? One of the obvious answers is mixins, but mixins comes with a lot of its own, watts, which we'll talk a bit about later, but this has been a pain point as well. Adam actually popularized the pattern of renderless functions, which kind of solved a lot of these problems, but we'll also discuss the cost of it. So a lot of you might be aware of the class API proposal. We opened an RFC for it, but we decided to drop it. So there will be no class API in Vue 3. So why? Originally, the class API was designed for better TypeScript support. But as we are iterating over it, we actually worked really hard, even had people from the TypeScript team to help us with a lot of things. But we just found that exposing props and other injected properties on a single this is just a lot of pain, even with classes. And it also has to do with the fact that a lot of Vue plugins tend to inject things onto Vue prototype or inject things by providing it on this context. So all these type inference can be really cumbersome. And one of the only seemingly plausible way to solve it is using decorators. But if you've been following along TC39, which is the committee that discusses new JavaScript features, they've been going back and forth on decorators for a really long time, and it's still stage 2. Stage 2 is not stable at all, right? And it went through several huge overhauls, and it just keeps changing. And it's now completely different from the way TypeScript currently implements underneath. So decorators is too risky to rely on if we were trying to design a new major version of the API. So we figured out that class doesn't really give better TS support. So what else does it really offer? Turns out not that much, except for its classes. So we just sat down and trying to figure out is it really worth it to just introduce another way of doing things if it doesn't really solve the original problem it is trying to solve? So we decided to drop it. And at the same time, we somewhat got inspired by React hooks. How many of you know about React hooks? Great. So React hooks was a bit controversial when it came out. So, but turns out leveraging Vue's own reactivity system. So the biggest benefits I saw in React hooks was the ability of freely composing logic using JavaScript. And turns out with Vue's own reactivity system, we can achieve something that's really similar. And I want to do a quick diving of the API here, because it seems I won't have enough time to go into full details. But first of all, one thing to remember, this API is purely additive. It won't affect the current 2.x API. So you won't have to rewrite all your code to just use this new API. Nothing is being deprecated by it. Second, everything here shown here is still in RFC status. It's not finalized yet, so some of the names, some of the naming, and some of the little things may change, but the general idea is here. So imagine we're building Vue ourselves with lower level APIs. What would you say are the building blocks of Vue? I would say the first thing comes to mind is the reactivity system, right? The ability to say make an object reactive so that when you change it, the framework knows something happened and do the things you want it to do. So let's say we have this API. There's a reactive API that makes an object reactive. So here we create a state object that's reactive, right? So how do we observe it and react to its changes? Let's introduce another API called watch. So we have this object, reactive object. So we watch. Inside the watch, we will use that reactive state. So now this API will apply this as a side effect. What I call side effect is something that your program permanently changed the state of the world. In here, we are mutating the DOM, right? That's a side effect. And you can think of this as just rendering, right? Obviously, in real frameworks, nobody's doing inner HTML, but for the sake of discussion, we're just imagine all the framework does is rendering in HTML using this reactive state that you just created. So during this execution, it will track this property that you used. So now if you do state.count++, it will cause this part to run again and update the DOM. So now with two very low-level primitives, we already kind of simulated what Vue is trying to do. Now how do we handle user input? Simple enough, we have a function that mutates the state. So, and we need to attach the listener to something, to the DOM, right? Obviously we don't want to do this ourselves. So let's leave that to the framework. And imagine Vue provides another API called render template. So this is completely hypothetical. This doesn't exist, but just imagine we have a function that does that. So it takes your Vue template, and it takes the render context. If you've rendered templates in any programming language, this should seem familiar enough. So what do we provide in the render context is what we exposed, so what all the things we can use inside a template. So we need to expose the increment function handler. We need to expose the state. So we declare the render context here, and this is all just the same code that we wrote before. And we use watch to do all of this so that the template is re-rendered automatically. So now this is very similar to what Vue does. And we can also have things like computed values. If we take a computed, return a computation inside of it, it returns a reference to the computation result. And because it may return primitive values, we kind of have to hold it inside an object, which is why we have to access it via .value. So we can, building up from the very low-level ideas, very low-level primitives, we can have a set of APIs, which you can imagine if you were using Vue today, right? Like the current API you are using are actually built with lower-level primitives like these. So this is what I call the lower-level APIs that we want to expose. And if we put all these APIs inside of today's component, this is a single file component. You would have the template, and you would put all the things that we just did inside a setup function, return the render context, and you have a component. So this is how we came from these lower level stuff to this. Think of it as an alternative way of expressing what your component is doing. You can totally write this with 2.x API, and it achieves the same thing. So now you might be asking, why are we doing this? I'm running out of time, but I'm going to fly through this. But if you're interested, please read the RFC. So one of the first benefits is with functions, we are able to organize code by feature instead of by options. One of the big downside of the Vue's current option-based API is, and one of the reasons why massive components become harder and harder to maintain over time, is every time you add a new feature, this feature is actually split up and spread across multiple options, right? It's not like all the code pertaining to a single feature lives in the same place. So look at this code. All the code relating to search are in one color, and all the code related to sorting the result is in another color, right? So they're split across. If you're trying to follow through the search logic, you would have to jump between this and this back and forth, trying to figure out where all the logic is. Imagine this getting worse as your component gets more features. You will be just having all these different colors right next to each other. Right? It's all fragmented. But if we have a way to say all the code that's working, that's related to a single feature should be able to live together. This screenshot is actually showing refactoring from this to mixins. But the problem with mixins is that they have namespace clashes. Right? So with the function-based API, you can actually organize your code like this. So feature A is just a function that returns some bindings. Feature B is another function that returns some other bindings. And then you just return these bindings to your template. So this way, you can cleanly separate your code logic by the feature they're related to, instead of by the options that you just happen to use. Right? So another analogy of this is single file components versus organizing your code by folders. Who still organize your front-end source code by languages extensions? Like you have a JS, CSS, HTML folders anymore? Nobody does that anymore, right? We have come to, I mean, your build output probably still does that, but like if you have a big project, right, you realize that oftentimes it's like for a certain page, you will have an HTML, CSS, JavaScript file for that page. So you would put those things together for that page, right? You organize your files by topic, by feature, instead of by whatever file it happens to be, right? This is similar to how you organize your code inside a front-end component, right? Instead of organizing things by whatever options they happen to touch on, how about we come from a different angle and organize them by the exact feature they're trying to deal with, right? So this is what this new API allows you to do. So, and this is something would help you to easier understand what's going on inside a component, because when you read this code, you see it kind of naturally describes what features this component is trying to deal with, and it's easy to follow through because when you see foo in your template, you go here, OK, it's imported by use feature A, you go into use feature A and figure out its details. It's always easier to trace where a specific thing comes from. And when you are looking at use feature A, you also see all the other things related to it right next to it. OK, so another benefit is reusing logic between components. I don't think I'll have time to go into too much of the details, but there's a case study. We can write the same listening to mouse position logic using mixins. Has a bunch of drawbacks, namespace clashing, unclear property sources. You can use higher order components, which is actually only worse. And then there's renderless components, which solves most of these problems, but it costs you extra component instances, which is a performance cost. So with the new function-based API, everything is just a function. So all the feature is just calling a function inside your setup function and returning the related stuff to your template. And there's no namespace clashing, and there's no extra component instance performance costs. So you can use it as much as you want without worrying it would eventually cause your application to be slower. And finally, there's better type inference. If you've ever used TypeScript, you notice code like this are naturally type friendly. There's no magic in there. It's just variables and function calls, which TypeScript is already really, really good at. And Vue will provide internal typing that just makes everything automatic. So, and the result is JavaScript code and TypeScript code written in the new API will almost look the same. They are just 99% identical, which is a nice thing because even if you don't use TypeScript, IDEs can still leverage the internal typing to do these hints for you. So this will benefit you even if you don't use TypeScript. OK, so that's it. For more details, you can check out the RFC. It's a super, super long thread. We're actually thinking of just doing a revision, just start from a clean ground so that people can have an easier time following through. So expect a new version of the RFC soon, and we're trying to finalize this. And as soon as we are done with this, Vue 3 will be really close to having its first alpha. So thank you.